Hi everyone, and welcome to an episode of Today You Learned. So today I want to show off a tool that I've been using lately a lot, almost every day, and the tool is actually called Binary Refinery. So I will demonstrate analyzing a malware sample using this tool. What is Binary Refinery? It's actually a set of no less than currently 300 different scripts, Python scripts or executable scripts that are compiled on Windows and Linux, so they work perfectly on almost every operating system, which is a big plus for this tool. And it is actually built to provide a command line interface to all the things that you can do with this tool, CyberChef. So CyberChef is a web interface where you can decrypt, decode, and so on, transform all kind of data and forensic stuff with inputs and outputs, right? So using pipe operators, we can actually use all the scripts within this binary refinery tool to analyze samples, files, executables, Word files, and so on and so on. So it's extremely versatile. It's for that reason alone, it's something I try to use on almost every pen test or in every research investigation that I'm performing, or even every CTF that I try to join. To install it, it's extremely simple and straightforward. You just can run a pip install binary refinery on your Linux or Windows environment, and then you can use every single command that it offers. For example, the emit command, right? So emit is actually one of the first commands that you will like to use. Every single of the 300 scripts and commands of binary refinery has a help option, which looks like this, which is very interesting, of course. And for example, emit will actually read a file or read some data that we so if I look at the files that I have in the current folder, this is the script I want to analyze in a couple of seconds. But if I specify something that is not a file, it will just emit the string that is here. So for example, another option of another script to encode or decode things, strings or data, would be base 64 at least. So base 64 to encode this not a file, and the /r is actually to perform the reverse operation, right? So /r would be to decrypt or decode, and if I don't do it at all, don't specify it at all, it will, well, encrypt or encode and decode, of course, right? Okay. So let's start by analyzing this file. So how does it work actually? To know all these different scripts, well, there is a very interesting documentation on the binary refinery solution. So like here we can see all these things. So emit will be among them as well, which would be here, right, where you can see all the information, and all other options. As you can see, there are quite a lot. So if I start by emitting this script, which seems to be a PowerShell script, if I look at it like this, you can see that it's not extremely large, right? A lot of PowerShell scripts are a lot larger. So this is probably malware. So the first thing we see is that there is a join right here of some data, and the data seems to be, well, delimited using different types of data, and we can actually see that right here. If we see that there is a split, PowerShell is a bit strange. If you offer it a split option and then an entire string, it will actually take each and every character of that string as a separate delimiter. So this split will actually split this and everything else, of course, and this. So based on every single character right here. It's a bit harder to do this kind of splits. You can of course do a split and then a pipe to another split and a pipe to another split. It's a bit harder to do that in Python, but this is of course perfectly doable. So how do we start with this? Well, the first thing we want is actually to carve out, to take out only the ASCII part of this string, so the entire string itself. We could just of course copy paste it. That's something we can do. Select everything and then copy and then emit paste it like this. This would work, but that's of course not so fun. So if I run an emit and then I use an option called carve, carve is also part of binary refinery, we can see that it will try to carve out integers, floats, strings, which is ASCII, which is the string parameter that we might know from other stuff, PowerShell strings and things like that. So if we try it with string, we can see that it carves out all the different strings. So there's an empty string, then we have our larger string right here. He also recognizes the parameters for the split option, and another one right here. So if I take a look at the help for carve, if we just want the single biggest match, we can just specify -s. So -s will only result in that single largest string. Another option, if the file is too large to print out, another option would be to use peek. So that's actually how you use Binary Refinery the most if you're analyzing files or malware. It starts with emit, and then whatever you want to do with it, and then it ends with peek, and peek has the upside of specifying or giving you some metadata. So it runs a file comment on this, a Linux file comment. I'm in Windows right now just to show you that it works in Windows. We have a Windows, it will do a file comment right here, so it recognizes at ASCII text. It looks at the entropy. It also gives us the size, the length of this entire string in this case. So the string is 7204 bytes long, and then here you have the exact data, and if the data is not really readable, here you would see the hex version of that. So peek is actually pretty powerful to show you, to decode, to escape stuff, and so on, if that's something you like. Okay, so now that we have this, a next portion would be, well, let's try to split it, right? So splitting in Binary Refinery, it's a bit harder, so let's find it out. Let's look for split, and then we can see that there is an option right here called split, but we are actually looking at if there's maybe there's a split command, but it doesn't seem to be the case. But what we do have is something called RE-split. RE-split is it says class, but that's also the name of the commands themselves. So it's actually splitting data given a regular expression. So we can use a regular expression to split data. The default, if you don't give it any regular expressions, is to use new lines, the two different forms of new lines. So in this case, that's something we want to do. We want to split, but not on new lines. We want to split on, for example, the character L, right? Not split, RE-split. So now he has split it on, he hasn't split it yet. I think I need to specify it like this. So now he has split it using the L character, not that bad, but of course we need to split it on the other ones as well. So if we take a look at the emission, what do we want here is actually to split it on each of those. So if I leave it like this, it will not split anything, because it will take this all as one single string, of course. But with regular expressions, if we want to use the OR parameter, we can use pipes like this. So normally, and maybe I will put it in a peek, normally if I just do it like this, it will actually split it into a large array exactly the way we want it. We do notice that it starts and ends with a single quote. Maybe we can remove that. The way to remove stuff in Binary Refinery could be with something called replace, for example, which we know from Python. That's how you would do it in Python. So we have REPL, which is a replace option. So we can look for something, and then if we don't specify a replace, then it will just remove it. So if I do something like this, I want to remove, so replace this single quote like this. With this command, we can see that the quotes are gone. Okay, so far so good. So now what do we have? We have an array of bytes, or bits even, that we need to convert into a hex array, right? Which is what the next part would be, what the PowerShell script does. So how can we force that? Well, there's also an option for that is very useful in Binary Refinery. It's called pack. If we look at pack, what pack actually does is he recognizes textual representations of arrays, like decimal or hexadecimal or binary or whatever, and then transforms them into a byte sequence. So if I run it like this with, for example, 2, because 2, so the base right here is one of the options. So 2 would mean that it is binary. If I do it like this, this is what we get. So now our entire array of binaries is actually converted into something that is quite readable, right? As we can see here, it looks like a read line option for PowerShell, which says nothing. He adds something to the registry, an office update check. So, and this is then something that is of course very interesting. We have an execution policy bypass and then some encrypted data. So we're closing in on what this portion of the script actually does. So closing in, but we're not yet there. Maybe we need another carve, but in this case I would try to carve out the base 64, which would be like this. If I do not specify anything else, he will actually also find out the strings that are in here. I'm also only interested in the larger one. -s is the larger one, which is this one, right? By the way, if you sort them, so he will put the larger one first, and then I'll only need the first one, which is this one, which is actually the same as S, right? Okay, so now we have that one. So this is the payload to be fed to the PowerShell command. So now we can actually decode that like this. So what this actually does or seems to do is it performs a wget of mimikatz, okay, without any printed output. So the next part is he sets a parameter, he gets computer information, puts that into the file that is in the parameter, so in data.ini. Then he creates an empty variable, and then in a while loop forever, he will get clipboard, and then if the clipboard has changed or is not empty, he will write it write the output and put it into the out file as well. So data.ini will contain the computer information and then continuously monitors and checks if something has changed in the clipboard. So this is a clipboard stealer, right? Or this portion of the script. So in a one-liner, and we can even make it shorter because this carve option also has a decode option, so we can actually add the D option right here to just decrypt the carved out base 64. If we specify it like this, he will also decode the other strings, but these are not base 64, so no use right here. So that's the first one. If we take a look at the carve of the strings right here, you can see that we now have decoded this one. There's another one right here which does the same. So to get that one out, there are two options. We can try to work with square brackets. So we can of course take out first so we sort them to length, so the two longer ones are first. If we take out the first two, we only get these two, and next we can actually run our tools on each of those if we want, right? So this, for example, will show them separately. So everything we put here, pack and so on, will be put will be done separately on every output. But maybe it's useful or more useful if we only found out if we only work on the second one right now. So let's try that out. One option would be if I feed it into peak, we take a look at the length. So this is 7204 because that carve option also has a length. So a maximum length matches must have length of at most n. So if I specify the length of max, for example, 7203, and then we take a look at the largest one, the single largest one, he will actually skip the largest one and we only have the second one to work with. Separate ways of doing the same, which is of course very fun if you have those different options. So in this case, I do want to do a new split. If we take a look at the script so that we know what to split on, it would be this one, right? So if we take a look at RE splits, and then we need to separate, okay, RE splits, we need to separate those. Okay, let me copy paste it like this. I mistype every time, so this way I'm pretty sure I haven't made any typos. So he will now carve this out like this, and he will split it on each of those separate characters. Let's take a look how that looks like. This is what we have. Looks pretty normal. This is actually how PowerShell mostly stores its data, its binary data or its data streams. We can pack this as well. I did not do a replace here because we will find out that the pack it's of course this one. That the pack will actually leave that out because it's not part of the octal view that we have here. So if we take a look, this is how it looks like. So this is the PowerShell code to be executed, and it's a bit more complicated than the previous one. It's a bit harder to read because it combines uppercase and lowercase characters. For this as well, there is actually a command, C lower, to lower everything. Can also be very useful if you want to capitalize certain strings in a CTF or something like that. So now it's a bit more readable. For example, we have a from base 64 that is actually being converted as a memory stream, then deflated, so it seems to be compressed with a decompress option, and then it is being encoded or stream read. So this is probably code that is actually shell code to be run in memory or put into memory and then executed. How do we know that it will be executed? And this is something I'd like to end with, just because it's very cool. So you might know this command. So get variable MDR. So let me show you how that looks like. Get variable MDR in PowerShell. In every single system, it will return maximum drive count. In this case, this is the value. It's not about this one, but it is about the fact that it reads out the name of this one. So the name would be maximum drive count, like this. So name. And then we only get the name. And if we take a look at what it is, it looks at character 3, which is maximum, 11, E, and then 2 is it's 0 based, so it's maximum right here, X, Y, E. So if I take a look at this, what do we get? We get IEX. If we then perform what we see here, a join, minus join, we get this, and this is a command that we know because it's invoke execution. It's to run data in memory directly from PowerShell, which is what is happening here. So it's piped into an IEX without actually typing IEX. So it's very inventive into getting this string loaded into memory. I leave it up to you to decode the string. The script can be found on the internet, or contact me. Thank you, and keep learning.